Hey, how's it going? My name's Austin Gill, and today I'm going to be wrapping up this series all about file uploads for the web. So far in the series, we've covered enabling file uploads on the front end and the back end. We've covered architectural decisions to reduce cost on where we host our files and improve the delivery performance. And I thought we would wrap up the series today by covering security as it relates to file uploads. Anytime I discuss the topic of security in any application, I like to consult the experts at OWASP.org. Conveniently, they have a file upload cheat sheet which outlines a lot of the attack vectors when dealing with file uploads and steps that we can take to mitigate against them. So today we're going to be walking through this cheat sheet and implementing some of the recommendations on an existing application. And just for a bit of background, the application is relatively simple. It's just a front end with a form that has a single file input that uploads that file to a backend. And we have a minimal backend that's powered by Nuxt.js Event Handler API, which basically receives any incoming requests as an event object and then detects whether it's a multi-part form data request, which for file uploads it must be. And if it is, it passes the underlying node request object or incoming message to this custom function called parse multi-part node request. And all the code we're going to be writing today is going to happen within this parse multi-part node request function, which once again takes an incoming message or the underlying node request object. So this should work regardless whether you're using Nuxt or Next or any other sort of framework or library that lives within Node, as long as you have access to the underlying Node.js internals. Now, the way this function works is it creates a new promise and then it passes the request object to this library called Formidable. Now, Formidable is one of the most popular Node.js multi-part form data parsing tools, which basically takes the node request object and then gives you a way to take out the fields and the files that are in the incoming request. So that's going to be our starting point today, but if you want to get some more details on the lower level concepts that apply when Node handles and parses multi-part form data requests, I'd encourage you to check out the previous video where we handled multi-part form data in Node and were able to set up handling requests with and without a library. One of the first recommendations in OWASP's list is extension validation. And this is a good technique to try and ensure that only the expected file types actually get into your system, and anything that is not of the right file type doesn't get in. Fortunately, this is pretty easy to implement with Formidable by passing a filter configuration option, which should be a function that has access to a file object, which contains some details about the file, including the original file name. So what we could do is create a regular expression that checks that a string ends with dot and then provide a list of acceptable file type extensions. And then we can check the original file name against that regular expression. For any upload that doesn't pass the test, we can return false, which will tell Formidable to go ahead and skip that file. And for everything else, we can return true, which will tell Formidable to go ahead and write the file to the system. Next, we can tackle Filename Sanitization, which is a good way to protect against file names that are too long or that include characters that are not acceptable for the operating system. Here, the recommended solution is to create your own file name for the upload on the backend using either a random string generator or UUID or some sort of hash. Once again, Formidable makes this easy for us by providing a file name configuration option, which once again is a function that takes a file and then just expects you to return a string. But we can actually skip this step because Formidable's default behavior is to generate a random hash for every upload. So we're already following best practices just by using the default settings. The next recommendation we'll tackle is setting an upload limit, and this is going to protect our storage capacity and how much we have to pay for storage, as well as how much data might be transferred if those files get downloaded. Once again, we get some basic protection just by using Formidable because it sets a default value of 200 megabytes as the maximum file upload size. If we want, however, we could overwrite that value with a custom max file size configuration option, which for example, here I set to 10 megabytes. So the right value to use here is going to be highly subjective based on your user's needs. Okay, next we'll talk about the location where uploaded files will be stored to. The top recommendation is to store uploaded files in a completely different location than where your application server is running. That way, if malware does get into the upload location, it doesn't have access to the running application. We covered an example of this in a previous video where I showed you how to store files to an object storage provider, which in addition to being more secure as we see here, is also a more cost-effective place to store those files. But if you can't store files on a different host, the next best thing you can do is make sure that uploaded files end up outside of the web root of the application server. So in this case, Formidable has us covered from a security perspective because by default, it will store any uploaded files in the operating system's temp folder. Although if you want to have access to those files later on, that's probably not the best place to store them. Fortunately, there's another configuration setting called upload dir where you can pass it either a relative path or an absolute path to where those file uploads should be stored. So for example, I'm storing uploads in this application to a folder that already exists in my project called uploads. Okay, the next suggestion we'll look at is content type validation. And this is important to basically ensure that the files that are being uploaded match a given list of allowed MIME types. This is similar to extension validation, but it's important to also check a file's MIME type because it's relatively easy for an attacker to simply rename the file to include a file extension that's in our allowed list. So let's go back to our Formidable settings and see in the filter that our file actually gives us access to the file MIME type. So we can create a different set of logic that basically checks the file MIME type to see that it includes something like image if we want to filter out anything that is not an image. Now this would be great in theory, but the reality is that Formidable actually bases the file's MIME type information based on the file extension. So it's not actually that useful. And unfortunately, this is likely to remain the case because Formidable's filter function is great at preventing files from being written to disk, but it can only do that as it's parsing uploads. And the only reliable way to know a file's MIME type is by actually checking the contents, which you can only do after a file has been written to disk. That brings us to the next issue. Last but not least, we'll cover file content validation. This is basically scanning the contents of the file to make sure there isn't anything malicious in there. So before we actually consider a solution for this, let's look at how the application works currently. I can go ahead and select from a list of several files, including 3 JPEGs and 1 text file, and note that one of the JPEGs is especially large. When I upload this list of files, we can see that the API request fails with a status code of 500. In the server logs, we can see more information that the 500th error code is because the max file size was exceeded. Now this is good because it's preventing a file from being uploaded into our system that exceeds the maximum file limit size. But we could probably do a better job of reporting a better error message on the response and a better status code like maybe a 403. Next, let's try uploading all of those files except for the one that's too big. If we look in our uploads folder, we can see that despite selecting 3 files to upload, we only see 2 of them in there. And that's because one of them did not match our file extension filter, which was the text file. We'll also notice that the 2 files that did get uploaded with a random hash value selected for their file names. And once again, that's thanks to Formidable's default behavior. Now there's just one problem with this system, and that is that this baddog.txt file is actually a bit of malware, and this baddog.jpg is that same file, but just renamed to a JPEG file. And I can confirm that by using one of the most popular Linux antivirus scanning tools, ClamScan. So if we run ClamScan on our uploads folder, we can see the 2 files in there. One of them is okay, the other one found a bit of malware. And so now you might be thinking, well, we can take that list of uploaded files, pass them through Formidable, filter out the ones we don't want, write them to disk, and then run a malware scan on those files and then respond to the user if it's okay or not. The problem is both content validation and MIME type checking both rely on parsing the file's contents, which means it has to already be written on disk. And doing that can add a lot of extra overhead to the request response cycle, which means users would be waiting for an extra long time before they get a response. So running a malware scan on every single upload request is probably not realistic, but there is an alternative solution. Remember that the goal here is to protect our application from any malicious upload, as well as protecting any user from any malicious download. So what we could do is take an upload request and capture all of the metadata for each file in that request and store it in a database somewhere. And we'd want to include the location of the file, as well as an extra flag that can be toggled on whether the file has been scanned or not. Next, we could have some sort of background process that scans all of the files in the database that are flagged as currently unscanned. If it finds any malware, it could remove them or notify us, and if it finds ones that are clean, it can update their entries in the database saying that they're scanned. And lastly, on the front end, if you're retrieving a list of files, you can either filter by those that have already been scanned, or if you want to include every file, including those that are unscanned, you can include the links to download files that have been scanned and are cleaned, or you can just present the metadata information for the files that are not currently scanned and give some sort of information that they're going to be scanned at some point. Now, that's all a bit beyond the scope of what we're going to cover in this video, but hopefully you still found this valuable in highlighting some of the security considerations to make, some practical solutions, and some conceptual approaches to dealing with malware and protecting your application and your users when providing uploads as a service. Before we finish up today, there's one more thing that I want to mention. If you're an Akamai customer, you actually have access to a malware protection feature as part of our web application firewall service. So I just wanted to show it off really quick because it's actually super cool. I already have my application up and running at uploader.austingill.com, and I've already integrated it with the Akamai Edge. But now I have it set up with a security configuration, which includes some of the familiar Akamai security products like Geo Firewall or Denial of Service Protection. But now we also see that there's this malware protection feature. And now if I explore this malware protection security policy and I look at the malware protection configuration, I can see that I have this custom configuration policy set up. And in this case, I have it configured to just deny any request that has a type mismatch or contains malware. So now if I go to my application and I select a file that I know has malware in it and I upload it, I can see almost immediately the response is rejected with a 403 status code. Now, just to be clear, that's logic that I didn't actually bake into my application. That's happening thanks to Akamai's malware protection. And I really like this malware protection product for a number of reasons. First, it's relatively easy to set up and maintain in the Akamai UI. Second, I love that I don't actually have to change anything in my application's logic to integrate the product. Third, it clearly works really well compared to some of my other solutions for preventing malware, and I don't have to constantly be updating some malware database because they handle it for me. And last but not least is the way it actually works, because instead of having to receive a file upload onto my server and run a malware scan against it, that malware scan is going to happen on the Akamai Edge node. So that malware that gets blocked never even touches my origin server, which is great and gives me a lot of peace of mind. Now, it's important to remember that security is not a one and done or silver bullet sort of solution. All of these things that we've discussed today have their own pros and cons, and it's sort of like an incremental addition to reach better security. So this has its own pros and cons, as well as all of the other features, and it's a good idea to add as many security layers to our application as we can, this just being one other additional layer. Okay, that's gonna wrap up this series on file uploads for the web. I hope you found it useful. If you did, please let me know by throwing a like on the video or leaving me a comment in the section below. I've really enjoyed having you here, and I'll catch you next time.